Hi guys, today I'm going to talk about some very important concepts in natural language processing (NLP), which is a domain in computer science that deals with the processing and analyzing of human language, particularly in the form of text. But even in the cases of speeches, speeches can be turned into text and then later analyzed, right? So some applications of NLP is that it can be used for sentiment analysis on text, on reviews, on tweets. You can use NLP for text summarization, for extraction of meaning from text. You can use NLP to build virtual assistants like Siri and Alexa and different chatbots, and the application of NLP is basically immense, right? And just by incorporating machine learning models into NLP, you can train a machine to recognize patterns in languages which otherwise only humans could, right? So yeah, so before we get into understanding how NLP is incorporated into different projects using NLP toolkits like Spacey and NLTK that comes in the form of Python libraries, I wanted us to go through some concepts which I believe is important for us to understand. Otherwise, things can get like very fuzzy very quickly, right? So let's go over some concepts. So the first concept that I want to cover is a concept called corpus. So corpus basically means a large collection of structured text. Corpus basically comes in the form of a dataset, right, that you can download from platforms like Kaggle, which is very popular for data science. Even like in some company websites, sometimes they make their data available for you to download. Government officials do that sometimes as well. So yeah, corpus is a large collection of structured text that comes with its own features, right, that you can download as a dataset and then do your analysis. The next thing that we need to understand is something called tokenize tokenization, right? And tokenization basically means breaking down bigger chunks of text into smaller pieces that are called tokens, right? So tokenization basically means breaking down bigger chunks of text into smaller pieces called tokens, right? And basically the corpus can be tokenized into sentences, and sentences can then in turn be tokenized into words, right? So this is the process of tokenization. Tokenization is breaking it down into smaller pieces. The next concept that we need to know is something called normalization. So normalization isn't just one step. It falls under the category of data pre-processing. It it's a it's some it's a collection of steps that you take to ensure that your data is uniform and consistent before the analysis, so that it doesn't create any conflict later on, right? So how do you ensure that your data is uniform and consistent? So one step of normalization is making sure that all your text is turned lowercase. That way, your text is case insensitive, right? But then again, you have to ask yourself whether doing so doesn't mean that some meaning is lost, right? Because sometimes in some situations, case can be very important, right? And lowercasing them could mean that some meaning is lost, right, in the process, which you don't want, right? So yeah, lowercasing text, make sure that everything is in the same case, and that way you it will not create any conflict later on, maybe when you're doing text similarity and stuff like that, right? So that is one step in normalization. Another step could be to find word equivalent for numbers, right? So an example could be one can be written instead as this, because the data type of one here is integer, right, and the data type of one is string, right? So you want to make sure that the data type is consistent throughout. That way it will not create any conflict later on, right? So that is normalization. The next step, the next concept that we need to understand is something called stemming. Stemming basically means stripping down a word to its base form which is also known as the stem word, right? So how do we strip down a word to its base form? So what we do basically in stemming is we eliminate prefixes, suffixes, etc., right? So basically, for example, if you have like running, the base form of running is run, right? So how do you arrive at the base form here? You just basically eliminate the suffix from running, and that's how you arrive at the base form. And why would you want to do something like that? Because sometimes in text you can have like multiple words that have the same meaning, although they are like there are different variants of the word, but they all mean the same thing. One example that I can think of at the moment is, for example, if you have like drinking, drank, drunk, these are all variants of the base word drink, right? So you don't want many variances, right? Because they don't necessarily mean a different thing. They all mean the same thing, right? So you want to perform some sort of steps that make sure that all of the words are in their base form. That way it helps in the analysis, right? It makes your analysis easier. um, and but then again, if you look at it, if you look at the example carefully, you would know that stemming is just like by eliminating prefixes and suffixes, right? But how do you arrive at the base word here, right? How do you arrive at the base word drink? For example, if you have like drunk, how do you arrive at the base word drink? You can't just like remove parts of the portions of the word and arrive at the base word in this case, right? So this is where a new concept comes in, which is called lemmatization, right? Lemmatization. So basically, lemmatization is similar to stemming, but it's different in the sense that it is aware of the fact that it's going to strip down a word to its most acceptable base form, acceptable, in other words, canonical form, right? So an example of lemmatization is like, for example, if you have the word better, which is a comparative word, the base form of this particular word, you can just like remove portions of the words to arrive at the base word here, right? So the lemmatization knows that the base word of better is good, and that's why in order to perform lemmatization, you generally need to feed it with some sort of dictionary, some sort of knowledge, right? So that it knows the base word of different words, right? Otherwise it can't arrive at that conclusion, right? So that's lemmatization. The next concept that we're going to talk about is something called stop words, right? We're going to talk about stop words. Stop words basically means some words that don't contribute much to the overall meaning of the text. There are some words that really don't add up, right? So, for example, articles are considered as stop words. Articles, as in the, and like they don't contribute much to the overall meaning. So what we do is we eliminate stop words before analyzing the text. That way the text that you're going to analyze becomes shorter and more manageable, right? Because they usually they add up a lot of text which do not actually add up to the meaning of the text much, right? So stop words are that we eliminate stop words, and you have to determine what stop words you want to include in the elimination process, right? So that is something that you need to determine. The next concept that we're going to talk about is something that you will be familiar with, is parts of speech, right? Parts of speech in NLP, it's also called post tagging, right? So as you may know, we have 8 parts of speech, right? Noun, pronoun, verb, adverb, adjective, preposition, conjunction, interjection, right? So you have 8 parts of speech. So by categorizing the text based on their respective parts of speech. It provides useful information for us to analyze, right? And also, like in future videos, you're gonna see that you can actually use that knowledge to visualize the text in a different way, right? And sometimes you may even want to associate pictures with words that are nouns, right? And do some other stuff like that, right? So that is parts of speech. The next concept that we're going to talk about is something called bag of words, right? So bag of words basically measures the frequency or occurrence of words, right? So bag of words measures how many times a word occurs in a particular sentence or in a particular passage, right? This information can be useful if you want to figure out if you have something in mind, right? And the how is it represented in programming language? Bag of words is represented in the form of dictionaries in Python, right? So for example, let me give you an example of how bag of words is used. For example, if you have a sentence, say, I love to read love stories. I don't, but whatever. I love to read love stories. You can represent that in the form of dictionary. So you could have, say, I occurs one time. The word love occurs two times in the sentence, and then the word two occurs one time, and so on and so forth, right? So that's how bag of words is used in Python and in NLP. The next concept that we have to talk about is something called n-grams, right? Now, what are n-grams? N-grams basically the n value changes, right? It can be one, it can be two, it can be three, it can be any number. But n-grams basically means that you categorize n number of consecutive words that you have in your text, right? So okay, let's just start by saying that if the n value is 1, the model is called unigram, right? And if the n value is 2, it's called bigram. If the n value is 3, it's called trigram. And basically, let me give an example of using trigram. So this particular thing, right, this particular sentence, if I use it again, I love to read love stories, then using the three, like the trigram, you will have something like this, right? So three consecutive words, I love to, these are going to be the outputs, right? Then the three consecutive words here, love to read, and then to read love, then read love stories, right? Read love stories. Now, how do you determine what is going to be the value of n in what situation? So a common convention is we use the n value 2 in when you have a smaller data set, right? And we usually use the n value 3 when you have a bigger data set, right? So that's the common convention. And why is it performed, we're going to see later on in the videos, where how it provides some useful information for us during the analysis, right? So the next concept that I wanted to talk about is similar to parts of speech, but it's a little bit different in the sense that it's called named entity recognition, right? Which is also called NER, right? It is basically classifying texts into some predefined categories, right? So the predefined categories could be person names, it could be organizations, it could be locations, with time, and etc. Right? So let me give you an example. Say, let me just make up an example. Say Elon founded Tesla in, when did he found? I don't know. Maybe in 2010, right? So so Elon is a name of a person, so it's gonna be person name, right? Person name. And then Tesla is going to be under the category of organization, and the 2010 is going to be in the category of time, right? So it's a very good way of categorizing stuff, and it provides very useful information for us during the analysis, right? And the next concept that we need to understand is something called semantic analysis, right? And semantic analysis basically means finding the meaning of texts, right? And although it sounds pretty simple, it's actually very difficult, right? uh, it's easy for us to understand the meaning of a text because we just happen to know, but for machines to understand the meaning of text, it's very difficult, because not only does it have to know the individual individual meaning of words, it also has to know what a collection of words mean, right? Right, so it has to take many factors into consideration. And many people, it's a growing field of doing semantic analysis, right? Many people introduce different models that tries to improve the accuracy of predicting the semantics of text. And in the later videos, we're going to see what is the accuracy level of the existing models that we have at the moment, right? So that is semantic analysis. And the last concept that I'm going to talk about, um, it's like going full circle, which is one of the applications of NLP that I talked about, is sentiment analysis, right? Sentiment analysis, which is basically used to determine the sentiment of a text. Now, the sentiment could be like a positive sentiment, right? It can be a positive sentiment which can translate to something like happy, right? It can have a negative sentiment which translates to sad or angry. It can also have like a neutral sentiment, right? So it's neither positive nor negative, right? It's somewhere in between. And you may use sentiment analysis on reviews to see if your product is receiving positive reviews or not, if people are liking it or not. Or you can have it on like hotel reviews and stuff. In my thesis, I use sentiment analysis on tweets, because I wanted to see what the opinion of people were on a particular subject, right? So I filtered the text and categorized them according to topics, and then I did sentiment analysis to see what is the public opinion on that matter, right? So yeah, you can perform sentiment analysis to see if people's opinion on a particular subject is positive or negative, or if it's polarized or not, right? And the output of sentiment analysis is basically a range, right? So it's either positive or negative, and the neutral is somewhere in between. So the output comes in the form of a range, right? So you could have like something like 0 to 1 or something like that, or like -1, right? Let me you could have something like that. So -1 being it's a negative sentiment, 1 being it's like the maximum positive sentiment, and the output is usually in the middle of somewhere, middle of that range, right? So that's it for this video. I think that's it for the scope of this video. I wanted to go over all these concepts that I feel is important for you to understand before we see how Spacey and NLTK is used to implement NLP in different projects. And thank you guys for watching. I'll try to add the timestamp in the description. And see you guys next time. Bye.